All right, so this lesson is going to be about atomic number and atomic mass. We're going to get into using the periodic table and how these two numbers tell you how many protons, how many electrons, and how many neutrons an atom has. So, the NOVA, the elements periodic table that I like to share with you, is set up this way. So just know if you're using a different periodic table, it's possible that these numbers might be in slightly different positions, but especially if you look at the periodic table, you should notice a pattern. Atomic numbers are always whole numbers. There's never any decimals on them. All right, whereas your atomic weight, aka atomic mass, almost always does have a decimal on it. There are some examples, like if you look at Copernicum, or really a lot of those in that bottom row. These tend to be the man-made ones, but these are generally going to have decimals. That way you can always tell them apart from each other when you are using different periodic tables. Another thing, even though these have decimals on them, when we use the atomic mass, go ahead and round to the nearest whole number. Okay? That'll just make your calculations easier. So, go ahead and open up a periodic table, see if you can answer a few of these things. Just so that you can make sure that you know how to be reading the information that you see on there. So, for example, I'll do the first column. Copper is 63.55, or you can round it to 64 for the atomic mass. Gold is AU. That is a lowercase u. That's important to keep. Atomic number of silver is 47. Mass of oxygen is listed as 16.00. Different periodic tables tend to list it as 15.99. So again, you're fine using 16. Element name of Ni is nickel. Atomic number of lead, that is Pb. So atomic number is 82. Not to be confused with its mass of 207. Symbol for uranium is U, and the mass of carbon is 12.01, or 12. So this is really important. Your atomic number, that whole number on the periodic table that every single element has, is always equal to the number of protons that element has. All right? This number cannot change. If you add a proton or remove a proton, you make the element something else. All right? So nitrogen only has 7 protons. If you were to add a proton, you'd turn that atom into oxygen. If you were to remove a proton, you would turn that atom into carbon. All right? So as we go on and discuss other things like isotopes and ions, you'll see that some subatomic particles can change, but never, ever the protons. Protons are unique to their specific kind of atom. Okay, so here's the basics of using your atomic mass and your atomic number to figure out electrons, protons, and neutrons. All right, I just want to clarify right now that this is for just like your standard base neutral normal atom. We're going to talk about ions and actually isotopes later and how this changes ever so slightly. But like we just talked about in the last slide, atomic number is number of protons. This will never change. Always. All right. For a neutral atom, your protons will equal your electrons because protons are positive, electrons are negative. So in order for you to end up being overall neutral, you have to have equal numbers of positive and negative. That way they cancel each other out. And then your atomic mass, all right, that value comes from the mass of your protons plus your neutrons. All right? So if you know your atomic mass and you know your atomic number, you can figure out how many neutrons you have. So the atomic mass is going to help you figure out your neutrons. So for example, chlorine. All right, if you go to your periodic table, you can see that its atomic number is 17. You can see that its atomic mass is 35.45. So I'm just rounding that to 35. All right, so using our rules up top, we can now determine how many protons, electrons, and neutrons chlorine has in its neutral state. So atomic number is always equal to the number of protons. So that means we have 17 protons. All right. You can assume that we're dealing with a neutral atom unless you were told otherwise. All right. So we weren't told that there's anything strange going on and this isn't neutral. So we need to cancel out our 17 positives with 17 electrons. And lastly, our neutrons, we can use this relationship here between mass protons and neutrons to calculate how many neutrons we have. So we're going to take that atomic mass, the 35, we're going to subtract our 17 protons, and that'll give us 18 neutrons. All right. So when it comes to using your periodic table, sometimes you'll be given the numbers like on the last example. Sometimes you're just going to have to go look up a periodic table and look these numbers up. All right, so then in that case, we're actually, even though they're written last, we're going to start with these columns. So if you go to beryllium, all right, Be, I'll go ahead and write that in there just so that I know. Its atomic mass is 9.012, so I'm just going to round that to 9, and its atomic number is 4. All right, if you remember your rules from the last slide, atomic number equals protons. All right, again, we're not being told that this isn't neutral, so we can say that protons equals electrons in this case, all right? And our neutrons are going to be equal to our mass minus our protons. So we can use those here. So atomic number is equal to protons, so that means beryllium has 4 protons. It's got to have an equal number of electrons, and our mass is going to be 9 minus 4, which equals 5. All right, you try some other ones. I'm going to ask you about uranium, and I'll do a few more after that if you think you need some more examples. So let's see, uranium has an atomic number of 92. It has an atomic mass of 238. All right, so atomic number is equal to number of protons, so this is going to be 92. Which means electrons are going to be 92, so that we cancel out and become neutral. And then our neutrons are going to be 238 minus 92, which is going to be 146, I think. All right, this makes total sense. Pause here. But if you want to see a few more examples, I'm going to try cobalt and gold. So cobalt, CO, has an atomic number of 27 and a mass of 58.93, so I'm rounding that to 59. All right, so atomic number tells us our protons. Since we're dealing with neutral atoms, that also tells us our electrons. And our number of neutrons is going to be 59 minus 27, which is equal to 32. And gold, which is AU, has an atomic number of 79, a nice even mass of 197. So our atomic number tells us protons. I'm doing this in iodine. 197, 79. So protons equals atomic number. Protons has to equal electrons to be neutral. And 197 minus, I do that in my head right now, 197 minus 99 is 118 neutrons. Okay, if you have questions about this, let me know.